2 in the morning, an app team told us the firewall was blocking a payroll service. Ping worked, so the network team pushed back. The vendor said, use telnet. Telnet was not installed. Somebody ran netstat, got 3 screens of ports, and pasted a screenshot into the ticket. 40 minutes later, we found the port was listening, but the wrong Windows service owned it after a bad upgrade. The failure was not a packet mystery. It was a tooling problem. The old commands gave us text. PowerShell gave us objects, process IDs, and proof. The manual way works until you have more than one server, more than one network interface card, or more than one admin typing commands differently. ipconfig is fine for looking at a screen, but ugly for comparing DNS servers across a fleet. Ping tells you Internet Control Message Protocol responded. It does not tell you the application port is reachable. Netstat can show process IDs, but then you are doing mental joins against Task Manager. At fleet scale, screenshots become folklore. You need commands that return objects, survive filtering, export cleanly, and can run the same way from your workstation against many machines. The core idea is simple. Stop treating network troubleshooting as lines of console text. On Windows, the NetTCPIP module and the DnsClient module expose the same practical information as the old tools, but as PowerShell objects. That means you can pipe to where object, select object, sort object, export CSV, or feed the result into a remediation script after review. Test-NetConnection replaces ping for basic reachability and replaces telnet for TCP port checks. Get-NetIPConfiguration becomes your filterable ipconfig view. Get-NetTCPConnection is your port table. Get-DnsClientCache shows what the local resolver already believes. Now troubleshooting becomes repeatable evidence, not keyboard archaeology. Start with Test-NetConnection. Run Test-NetConnection -ComputerName server 01 -port 443 -InformationLevel detailed. Without -port, you are mostly checking reachability. With -port, you get a TCP test that replaces the old telnet habit. For listening in established ports, use Get-NetTCPConnection. Add -state listen, then select LocalAddress, LocalPort, and OwningProcess. Pipe that process ID into GetProcess if you want the application name. Get-NetIPConfiguration gives the everyday ipconfig/all view, interface, address, gateway, DNS. Get-DnsClientCache shows cached names, record types, data, and time to live. For controlled changes, Set-DnsClientServerAddress sets DNS servers by interface alias or index. Here is a real help desk-style ticket. After a DNS cutover, several finance workstations still resolve an internal app to the old address. First, check the current adapter view with Get-NetIPConfiguration and look at DNS server. Then test the new resolvers directly with Test-NetConnection -ComputerName 10.0.0.10-port 53. TCP53 is not the whole DNS story, because normal lookups often use user datagram protocol, but it proves the listener path for many environments. Next, run Get-DnsClientCache and filter the record name for the app. If the cache still holds the old answer, you know why the user sees it. For the cutover script, enumerate up adapters and preview Set-DnsClientServerAddress with -whatif before any change. A few scars. First, ping failing does not always mean the host is down. Internet Control Message Protocol may be blocked. Test-NetConnection-port can succeed even when ping fails, so read TCP test succeeded separately. Second, OwningProcess is a process ID, not a friendly name by itself. The process can exit between your two commands, so handle errors. Third, Get-NetIPConfiguration is the practical replacement for ipconfig/all, but for media access control address, driver, or link speed, pair it with Get-NetAdapter. I use PowerShell 7 by default, but these are Windows-only modules. On stubborn older images, Windows PowerShell 5.1 may import them more reliably. These commands sit right in the administration tier because they turn one server troubleshooting into fleet administration. Incident triage asks, is the port open? Which process owns it? What address did the client resolve? And which DNS server is configured? Change validation asks the same questions before and after maintenance. Inventory work asks for a clean table, host, adapter, IP address, gateway, DNS servers, listening ports. Once you are comfortable locally, the next step is running the same checks through PowerShell remoting or common information model sessions. then exporting results for an audit trail. That is the path from console comfort to controlled automation. Take 10 minutes on your own workstation or a test virtual machine. Run Get-NetIPConfiguration and select interface alias, IPv4 address, and DNS server. Then run Test-NetConnection against an internal web app or Microsoft.com with -port 443. Next, run Get-NetTCPConnection-state-listen and build a table with LocalPort, OwningProcess, and the process name from GetProcess. Look at Get-DnsClientCache and filter for a domain you visited today. Finally, practice the DNS cutover shape with Get-NetAdapter, where status equals up, piping into a for each object that calls Set-DnsClientServerAddress with -whatif. Do not change production DNS as a lab exercise. 3 takeaways. First, Test-NetConnection-Port replaces a lot of ping and telnet muscle memory because it checks the thing users usually care about, the TCP service. Second, Get-NetTCPConnection plus OwningProcess gives you the netstat view with a path to the actual application, which ends blame ping-pong fast. Third, Get-NetIPConfiguration, Get-DnsClientCache, and Set-DnsClientServerAddress make IP and DNS work scriptable, reportable, and safer to validate. In the next administration episodes, we keep stacking these object-based habits into remoting, auditing, and fleet checks. New PowerShell episode daily on this channel.